Okay, let's dive right into this explainer. Look, if you operate an industrial plant, chances are you're sitting on a massive hidden gold mine. Today, we're going to completely reframe how you look at the so-called waste coming out of your steam systems. As an energy expert, I see this literally all the time. We're talking about condensate return and why capturing it is hands down one of the highest value efficiency measures you can implement right now. Let's get into it. Take a look at this massive number. $835,003.20. Now, that's not some theoretical best-case scenario projection. According to the engineering data, that represents the annual energy loss for a typical 44,000 pounds per hour steam plant that just fails to return its condensate. I mean, we're talking about nearly $1 million evaporating into thin air every single year, just in wasted heat energy. So it begs a pretty simple question, right? Why on earth are you flushing this down the sewer instead of pouring this incredibly valuable asset down the drain, which, by the way, actually costs you extra money in sewer disposal penalties? We really need to talk about recovering it. Our sources are absolutely unanimous on this. Capturing condensate is one of the absolute highest payback measures in industrial engineering. Let's break down exactly why that is. Section 1. What is condensate return? Before we get into the heavy math and the incredible savings, let's make sure we're on the same page about what we're actually dealing with here. The crucial point to understand is that condensate isn't just dirty industrial runoff. When steam transfers its latent heat to your process, whether that's a heat exchanger or a heating coil, it turns back into a liquid phase. But this liquid, the condensate, still retains between 16 and 25% of the original steam energy, depending on your pressure. It's not just hot water. It's highly treated, sensible heat-loaded, boiler-ready feed water that contains valuable chemical treatments. Honestly, it's essentially premium fuel for your boiler. A proper setup treats this condensate with the respect it deserves, using heavy insulation on the receiver tanks and the piping grid. If you don't insulate all your condensate devices, literally every tank, pipe, and valve, that traps thermal energy just bleeds right back into the atmosphere before it ever reaches your boiler. You really want to maintain that high energy state every single step of the way back to the plant. Section 2. The ROI of recovery. All right, let's break down the triple threat of savings and build a totally bulletproof business case for recovery. Returning hot condensate saves fuel. That's obviously the big one, because your boiler doesn't have to waste energy heating up freezing 55-degree raw makeup water. But it also slashes your water supply bills. It cuts down your sewer disposal penalties, and it drastically reduces your chemical treatment costs, because that water is already purified. Like I said, an absolute triple threat of efficiency. Here is a super practical key performance indicator, straight from the Department of Energy sources. If you return just an additional 10,000 pounds per hour of condensate, you yield over $121,000 in combined annual savings across water, sewage, and fuel. That is real, tangible money going straight to your bottom line for a relatively minor system adjustment. And the best part? It pays off year after year. Let's look at the chemical impact in the real world with this meat processing plant case study. Notice how the baseline at 0% return compares to a 75% return rate. By scaling up, they nearly cut their oxygen scavenger chemical needs in half. They went from almost 6,000 kilograms down to barely 3,000. Why? Well, hot condensate naturally has very low dissolved oxygen. Less oxygen means fewer costly chemicals needed to scrub it out of the system. It's really that simple. And this scales up beautifully in heavy industry too. The sources highlight a specialty paper plant that managed to reduce its raw boiler makeup water rate from 35% down to between 14 and 20%. Just by returning that additional condensate, they banked over $300,000 in annual savings. It just goes to show how tightening up your makeup water reliance translates directly into massive capital savings. Section 3. Common condensate system mistakes. Okay, to actually capture these savings, you have to avoid some major pitfalls. This first one is a massive issue in plant piping: connection location. Branch lines must always, without exception, connect to the top dead center of the main horizontal header. If you connect to the side or the bottom, the cooler condensate and flash steam will violently interact. This causes destructive water hammer, which can literally tear your pipes and valves apart over time. Definitely something you want to avoid. There are two more huge piping mistakes you've got to watch out for. First, undersizing your lines by treating them like standard hot water pipes. Condensate piping is a totally different beast. You absolutely must calculate for two-phase flow. That means accounting for both the liquid water and the expanding flash steam gas. Ignore the gas, and your pipes are undersized, creating a ton of back pressure. Second, using standard threaded pipe connections. Condensate systems produce carbonic acid, which will quickly eat those threads alive and lead to dangerous leaks. And when it's finally time to actually move that fluid back to the boiler, your pump choice really matters. The data shows a stark contrast here. Old steam motive pumps, they cost about 8 times more in energy per year, carry high cavitation risks if temperatures get too close to boiling, and frankly, they suffer frequent mechanical failures. Electric pumps, on the other hand, give you continuous flow control, dramatically lower operating costs, and routinely exceed 6 years of totally maintenance-free operation. It's a pretty clear choice for reliability. Section 4, the 5-point action plan. All right, it's time to claim your hidden gold mine and turn all this theory into reality. Follow these exact steps. Step 1, target a 90% condensate return benchmark. Step 2, eliminate those vulnerable threaded pipes and upgrade to welded stainless or at least Schedule 80 carbon steel to fight off that carbonic acid corrosion. Step 3, audit your piping and enforce those top-dead center branch connections to prevent water hammer. Step 4, ditch the clunky steam motive pumps for efficient electric models. And Step 5, insulate every single valve, pipe, and tank so that sensible energy actually makes it all the way home. Section 5, stop wasting your steam. Let's wrap this up and look at the big picture of your plant's efficiency. The engineering sources make it crystal clear, stating that condensate is one of the top 5 items that must be targeted in a steam and condensate system to reduce energy cost, reduce emissions, improve optimization, and increase reliability. Look, this isn't just some nice-to-have environmental initiative. Recovering your condensate is an absolute necessity for any competitive industrial plant that wants to stay profitable and efficient. So, I'll leave you with this provocative thought to take directly back to your boiler room. What is your plant's current condensate return benchmark? Do you actually know your current return percentage? And more importantly, how much money, energy, and water is draining away down the sewer while you figure it out? Thanks for joining me on this explainer. Now go audit those steam lines.